Here is an interesting question on buffer solution. It says a buffer solution is made from 0.1 molar acetic acid and 0.1 molar sodium acetate. A. Calculate the pH of the sodium acetate. B. If 0.05 molar hydrochloric acid is added to the buffer system, calculate the new pH. Given is the pKa of acetic acid, which is 4.74. Henderson-Hasselbalch equation is the equation that governs a buffer system. That is the equation that governs the buffer system. We know that pH was not given, but the pKa of acetic acid was given, and the value is 4.74. This is a concentration of the undissociated acid. The acid in this case is acetic acid. It was given as 0.1 molar. This is a concentration of the conjugate base, or the salt of the conjugate base, which is this, sodium acetate. It was also given as 0.1 molar, so they are equimolar. They are equimolar of equal concentration. What is remaining? pH. So we repeat this, but plug in these figures into this equation. So the pH of the system will now be pKa, which is 4.74, minus logarithm to base 10 of this over this, which is 0.1, and we have pH as 4.74 minus log of, if you divide the two, you get 1. So the pH will be 4.74 minus log of 1 is 0. So our pH is equal to 4.74. This is A. The pH is 4.74. Now let us go to the B part of the question. This is where an acid is added to the buffer system. And this is the buffer system. The buffer is made up of acetic acid and sodium acetate. So in the solution, acetic acid ionizes to form acetate ion and hydrogen ion, while sodium acetate ionizes to form acetate ion and sodium ion. Now, both of these acetate ions are the target of any new acid that is introduced, because they are the conjugate base of this acetic acid. Now, when HCl is added, HCl is 0.05 molar. When HCl is added to this system, remember, the acetate ion is 0.1 molar. Now, HCl will attack this acetate ion, thus HCl plus acetate ion. What happens is that this is a stronger acid, and this is a conjugate base of the original acid, which is a weak acid. So the hydrochloric acid will protonate this conjugate base, and we have the CH3 COOH plus chloride ion, which may attack sodium ion in the system. So you observe that the presence of this hydrochloric acid, which is 0.05 molar, has converted some of this 0.1 molar to the original acetic acid. Common sense will tell you that when 0.05 molar of this hydrochloric acid is introduced, it will react with exactly 0.05 molar out of 0.1 molar of the conjugate base, which means this conjugate base decreases in concentration by 0.1 molar minus 0.05 molar, because 0.05 molar of hydrochloric acid will take 0.05 molar of the conjugate base, and the new concentration will be 0.05 molar. Now, remember, 0.05 molar of the conjugate base was converted to the acetic acid, which means acetic acid increases by 0.05. Acetic acid increases by 0.05, meaning the original concentration, 0.1, increases by 0.05, which is 0.15 molar. This is what this small amount of acid has caused. It has caused a decrease in concentration of this by 0.05 and an increase in concentration of acetic acid by 0.05. Meanwhile, using the equation of buffer solution, our new pH will be pKa, which is constant 4.74, minus log of, this is now the acetic acid, CH, and this is the conjugate base, acetate, or you say sodium acetate, the same thing, okay? Then we have pH to be 4.74 minus. Remember, hydrochloric acid increased the concentration of the acetic acid by 0.05. So it has to increase by 0.05, meaning that the original concentration will increase by 0.05. And this one decreases because that is what the hydrochloric acid attacked directly. So 0.05 of this will be removed from the original concentration, 0.1 minus 0.05. At the end of the day, this is what we have, 4.74 minus log. 0.1 plus 0.05 is 0.15. 0.1 minus 0.05 is 0.05. pH will be 4.74 minus log 0.15 divided by 0.05. If you shift 0.2 times 1, 2, you get 15. You shift 2 times here, 1, 2, you get 5. 15 divided by 5 will give you 3. So, pH will give us 4.74 minus log of 3 to base 10. Log of 3 to base 10 is 0.48. Therefore, pH will give us 4.2. This is the new pH, the B part of the question. I hope you got value. If you did, click on the plus sign and follow my page on TikTok and keep watching Chemistry Made Easy.